Good day. This is Jason Strait with the Past Cloud Virtual Chapter. Today we've got Satya here. He's going to be presenting Big Data with Azure, Where to Begin, Concepts and Best Practices. And getting a little bit of a late start here. So Satya, are you there?
Yes, I'm here.
All right, great. Yeah, for one time in the last couple years, I've got a meeting that actually butted right up into this. So I do apologize to everyone for this slow start for today.
That's
Before we
fine.
get started, I do want to make just a couple quick announcements. So the first announcement is that this webcast is brought to you by Spotlight Cloud. Spotlight Cloud is the first Azure-hosted database performance monitoring solution focused on SQL Server customers. Leveraging the scalability, performance, and built-in security of Microsoft Azure Cosmos DB, Spotlight combines the best of the cloud with Quest's engineering insights for years of building database performance management tools. This virtual group is part of a large number of other virtual groups that PASS does provide to the community. And with that, that was my quick set of announcements since I got a little bit late on getting us kicked off here today. And so our presenter today is Satya, and his session is Big Data with Azure, Where to Begin, Concepts and Best Practices. And at this point, I'm going to make Satya the presenter.
Thanks, Jason.
And I will mute myself unless anything comes up.
Sure. Let me share my screen and yeah, hope everyone can see my screen. That's good.
Yep, can see it and it's coming through great.
Good. Okay, let's begin. Thanks, Jason. Thanks for the introduction, and obviously thanks to our sponsor, Quest, for making this happen today. Good day, good morning, good afternoon, good evening from wherever you are in this world. So welcome to the session, Big Data with Azure, Where to Begin, Concepts and Best Practices. So this is to talk about big data and within Azure, what capabilities that we have, how the cloud can help us, and especially the Microsoft Azure. Little intro about me in terms of who I am, where I'm from. So just I know this is something it's always interesting. I have overall 26 plus years of IT experience. I live in Scotland, sunny Scotland. Yes, as I say. It is always sunny and the weather is absolutely nice today. This is my 148th speaking engagement and virtually as well and in presence and all that. And I've been pretty active, very active in the community across SQL Pass, TechEd that used to be in SQL Bits, SQL Saturdays across Europe and as well as in US. I have on SQL Saturday coming up as well in month of June in South Florida. Also other things I do enjoy kind of reading and sharing the knowledge, and that's where I got my MVP, Microsoft Most Valuable Professional Achievement since last 13 plus years. So, and I do travel a lot. That's my interest as well. So far 55 countries I've completed, so a lot more to go. And this is my, my email address and all that. I'll be sharing the slides at the end of this session, so you can all get that and you can download these sessions and free to use for your own kind of development and engagement. So I'm more than happy to share them, and if you want to keep in touch with me, more than happy to connect via LinkedIn. Right. Let's talk about what we have today actually. Okay, what we talk. Just data, right? Because we all like data, small data, big data, all data. So everything that's happening, and we are geeks. That's why we are here today. So I set a stage in terms of what we're talking about in terms of the aspects of the session. So let's begin with, as we talk about clouds. So let's begin from the cloud. Okay, how does it looks like? It looks serene. It looks nice. Just to start on a lighter note, this was one of the the cartoon that I've come across a couple of years ago, and it was really interesting and funny. It was a big data is going to impact us soon. That was means impact of that. And then somebody saying that called Bruce Willis. If you remember the movie like Armageddon, I think that's where how they go up and they blew up that. In the space. Anyway, just to keeping aside, but begin with something on a lighter note. this is not what we need to worry. We don't need to worry about how it's going to impact. But just begin with from where we are exactly to see, okay, what differentiates in today's thriving organization? Obviously, the question is nothing but, data, right? Because the data that comes, data is currency that, as we see, companies can take advantage of those data, like to perform the potential activities, potential business, activities, and as well as what asset is more leveraged by today thriving companies is obviously data. And you constantly hear in the news, we always hear and new ways of how businesses are using the data as a competitive advantage. And we also hear the people how organizations are making it fast and more like a decisive kind of, the achievement that it's been kind of, it was not possible until a couple of years ago, but now it is possible. Everything is available on the go. So that's how, that's the main key aspects of how organizations are taking care the advantage with data. And we do have a strategic opportunity with the data, because if we have a, kind of on the left-hand side on the screen, we can see how the technology can use or how technology can help us to get this innovation and how business can architect that into there. So setup change is constant, because that's what I say, that you're being asked to do more with less, obviously. And this is where exactly it gives, like, we always have that, like in the middle, meet in the middle in terms of how best we can kind of combine the IT technology, the technology aspects, and how the business can take advantage of that. This would be the strategic opportunity with data for any organization that I see over a number of years. In terms of how we can set the scene in terms of, I would say that how it used to be, these opportunities, this is where exactly we have, it used to be data center previously, and then now it came, since last 10 years, it's now cloud, right? We must go beyond the data center because we need to expand its value into the cloud, as well as, the next in terms of now it's happening is edge, IoT, Internet of Things. The view is not limited, it's just a network topology or architecture discussion that you say, but the new business models are available from the cloud and by the cloud in terms of when it comes to the edge and IoT. And when you look at these true disruptors, I would say disruptors in the market, where we can see there are many, many companies who are there, like names like Uber, Spotify, Airbnb, and these applications, how they leverage these disruptive technologies, actually, how the mobility and devices are kind of endless opportunities for the user, for the organizations, for the business. It's not only that, actually, we can develop our own data. It's like bring your own data. We need to digitize that and combine that into how best we can take advantages for use of these activities. Just setting a stage of how does from traditional data to big data it looks like in terms of the underlying, as we can see, data complexity is a variety and velocity, but in terms of the storage, how it used to be, like traditionally it used to be ERP, CRM systems. They are such as, the ERP systems, they go between megabytes to gigabytes. And then 10 years ago, 15 years ago, Web 2.0, that's where it just exploded into kind of, okay, how online the business is taking advantage of online and as well as the mobile capabilities. But now the scene has been changed. Now it is more like a big data. What is a big data? We'll go into that details about what's that, how you can classify that. As you can see, the strength of the data, how the storage is increasing from megabytes to the petabytes, and it's even increasing over a petabyte as well. Everything that we see on a day-to-day this is what's happening, how the data has become now a traditional way to the big data. Just to give you a notion of how it looks like, starting from a 1 bit, which is just a grain of sand, and how these 1 megabyte used to be. Until 10 years ago, I think if your database size is 100 gigs, then that is classified as a very large database. Now it's not anymore. Even it is 2 petabyte, it's still considered as a database, and how it has become, like you can see the differentiation of how it is growing. And this is all possible from the technology, how the innovation, how it can kind of take into that. So taking a step back into data warehouse traditional approach, right? from left to right, source systems, you have OLTP, transactions, ERP, CRM, and some LOB systems that goes into staging layer. That's where we perform our extract, transform, and loading, ETL, and then goes traditionally the staging strategies using into data warehouse, where we have multiple areas of how it can be transformed as a multiple data models. Files, they are kind of, yes, that's how easy to work with. And the queues, this is how the data warehouse has been matured over a period of time, and it can scale out better than files. And that's how it has formed into databases. Now it's more like transactional consistent, so that you can manage the consistency of data. It can do, but it's increasing now, right? How this data warehouse, how this traditional approach is done is a batch processing. But batch processing is a history now. As we can see, data is collected and processed in batch files, right? How the batch is used to be like, let's take for example of the paychecks, how our paychecks used to be processed, a batch processing in the end of the month, and how companies are responding, like how they can go into out of that actually batch processing, which is called real-time processing, right? The companies, the organizations need to respond to this growing non-relational data by implementing some environment that requires adopt to new ecosystems, new languages to write, new language to program, and there is a steep learning curve in terms of manage these everything into the infrastructure, right? That's a new age data types are quickly becoming integral part of any organization, as I say, and this is what it is, and we can see that now there are many more organizations are adopting into the cloud, and how it can done in terms of there is at least 50% of organizations across the world they are deploying into a cloud, and especially for big data side. That's what it is in terms of real-time decisions and processing, right? There are certain examples of scenarios of how real-time analytics will be helpful in these business areas actually. For example, taking real-time fraud detection for financial organizations. Not only that, these cars, as we hear about driverless cars nowadays, and also how your car connected using GPS, and also not only that, what's happening in over the drive that you do. Not only that, in healthcare, real-time patient monitoring is also one of these real-time analytics scenarios coming. Not only that, within IT, it gives us the ability to monitor, detect, and take a proactive approach before even the disaster is about to happen. And obviously in retail markets, within inventory management and real-time, how customer behaviors and all that, it's been taken into. As you can see, it has becoming an integral part of your day-to-day life as well, real-time analytics. With this, there are certain breaking points, right? Obviously, because the data gets exploded, and with this new type of data in terms of, as we see, from sensors, from social networks, from devices, also from the web, in terms of, increasing data volumes, that makes it difficult for any transactional or any data warehouse kind of environment. This unstructured data, as we call, more like new data types. The new data type is now is a cloud kind of data types, like how these are contributing factors to this traditional approach that can break down, and it's not possible to go in a traditional way of doing a relational database approach, relational data warehouse approach. That's where it becoming like, if you divide the workload types here, I just want to take one little example here, as we can see on the top right hand side. This is real time. In real time, in terms of volumes and the real time processing, we call about interactive analytics. That means user need to get that the response need to be in a milliseconds. It used to be seconds before, or it used to be minutes, but anyone waiting for more than 10-15 seconds, that normally tends to be a very bad application. That's what it is, real-time processing. How it can help in terms of infrastructure, having that on-premise, yes, it comes with a cost. Obviously, cloud is here for us to make this happen as soon as possible. Big data, this is where exactly we have in terms of what is a big data in terms of device explosion, in terms of social networks that we have over a period of time. Enormous amount of data generated for last, I think, 5-6 years, even last 10 years, you can see there's a lot more kind of things are happening. 90% of data that's there out here actually has been created in the last 2 to 4 years now, and 40 trillion gigabytes size of, that's what it is. By next year, it'll go beyond that actually. So that's the expectation. So in a normal terms, in a plain English terms, or in terms of big data is nothing but a high volume, high velocity, and high variety information assets that give us a cost-effective and innovative forms to process the data that can help business to get an enhanced insight, and they can make a better decisions and also process the data as and when it happens. As and when, that means it gives back to that. With this, we have a notion of, when you talk about the big data, it used to be when big data began 3 V's. Now it is 5 V's. What are those? Volume, which is the size of data the process is large. When we talk about large, it can go beyond terabytes. It can go beyond even the yottabyte, as we have seen the slide before. And data needs to be processed in parallel across multiple systems. That's a volume. And data needs to be processed once and processed to completion due to the volume. So it needs to be kind of revised that, and results need to be pre-processed. That is first V. And the next thing is velocity. Data needs to be processed at a streaming speeds. Actually, it's not just data that comes and check the data, it streams. The data streaming happening as we collect the data. Data needs to be processed at multiple acquisition points. That means the number of points we have, number of data acquisition points, we need to make sure that it is processed. And the third way is variety. It comes different form. It's not just a simple kind of relational data anymore. As we can see, non-relational and unstructured data. Structured can be in any form. It can come from any variety of any region as well, right? And as well as and the fourth way is veracity, right? In terms of it is ambiguous in nature due to lack of, we don't have relevant metadata or context in many cases, right? How it can make meaningful of that actually. Authenticity in terms of how you can kind of look into this and say that, yes, this is the correct data, or how you can develop from multiple data sources into a single source of truth for the data. And the value, right? The value is easy to, as it said, but there is a certain complexity to that actually, because there are certain models and algorithms need to be managed, to be developed so that you can process the data and get a meaningful value out of that. So this is where data scientists and data, engineers can add value to this actually, to process, to look into the data and scalable, build a scalable models that can import into the business. That's where the value comes out of the picture. So these are 5 V's whenever you talk about a big data. That is always how business would look like how a non-IT person can look like into it can do that, right? How big is a big data, right? Everybody is saying big. How big is a big? This is what it is actually. In Azure, as of now today, we have 1.8 trillion requests of Azure Event Hubs. That means that's happening as we speak. And there are 216 billion emails per day that happens, and as well as 4 million nearly hours of content uploaded to the YouTube, and the searches in terms of Google or in terms of Bing. This is what is happening. So this is all the big data is whatever is happening. So how the organizations or how the business are taking advantage of this is miracle. We can say how cloud or how technology is getting helping us in terms of to get this. Obviously, with new systems, new technologies change, there are certain challenges is always there. So as to the big data as well, right? First things first, I would say that determining how to get a value, right? You have a data, you have traditional data at your end, and as well as a legacy data at your end. So how you can combine these two and to get a value out of that actually. Not only that, how can obtain the skill set in terms of the capability, build the skill set and capability within the organization is also more important. And not only that, we are not saying that you just throw away whatever you have, you start fresh with big data. No, you need to integrate that data migration in terms of the existing data and the new data, how you can combine and how you can kind of enrich that by using existing IT investment that we have. So this is where exactly we have certain technologies and features. It can help to that. I just want to give a little bit about the big data and AI landscape until end of last year. These are the main contenders of how it looks like. So let me zoom in terms of how does it looks like in the screen. I'm not sure whether it's been Yeah, it's zoomed in. So as you can see on the analytics part of that, actually, we have these many companies or these many organizations. These are open source. These are certain organizations, or you can use it for open source, and certain organizations are vendor specific. Obvious reasons. Obviously, everything needs to be kind of pay like per use. And this slide has been developed by the gentleman called Matt Turk Demi Obayami by the organization called FirstMark. So you're free to use that actually, and this is where I got them, and they update that every year. So this is just to give you a notion of what is a landscape, what are the different players or different applications can be used in terms of that. This is just for information, just to blow of mind. Right, jumping back into Apache Hadoop, right? What is Apache Hadoop actually? It started as back in 90s, end of 90s actually. Apache Lucene, which was it was free and which is still free actually, a full text search library. And it can be used to analyze normal text, the purpose of developing an index, right? This is again traditional way of how you can kind of search into within the database. And the index maps each term, remembering its location, and the term is searched for. This is where exactly Lucene has come into more, much more aspects of it. Makes search process much faster and more efficient than having to seek term out anew. Each time it is searched for, it kind of stores that value so that the metadata is kind of done. So this is where exactly, Doug Cutting, who has kind of invented this and kind of started with Apache Software Foundation. So this is where, and in 2002, Lucene became popular and joined by Mike Cafrella. So they pulled more into storage components and how they build into much more into kind of applied into the Hadoop, which is a programming model, and as well as the MapReduce, which is developed by the Google. And this is where exactly it started working into that. So this is where the fact is Apache Hadoop is free to use, it's open source, and it is highly scalable. That means the file system, it is mentioned as HDFS. So these are the things which you hear a lot in terms of that actually. And it stores in a distributed file system. So it comes kind of, stored in many kind of servers. And it can store large amount of data actually. And this is where it stands out from the traditional relational data warehouses or databases. What are the resources and techniques in terms of do use, right? When we talk about resources, when we say processing capabilities, obviously we go to system administrators or our storage network saying that we need more memory, we need storage and network, right? And this having the capabilities of increasing more into that actually is a data intensive. That means it can be complicated process if we talk about this in the kind of, on-premise, kind of situation or traditional way of how it is being done, right? But now it is possible to deploy everything online as it happens, and as well as to scale up as well. In terms of the system should set and optimize of, how the configuration patterns, how you can do that. And we need to support this big data processing and the analytics at a global scale or even at a large scale in terms of how scalable infrastructure can help us to do that. And this is where the cloud capability, cloud computing provides the ideal environment for data processing and storage demands through the cloud flexibility and the scalability. There are certain things to that actually. I know the outsourcing nature of clouds has got its own, privacy issues that can impact many domains such as financial. It cannot go beyond this kind of thing. This is where Hadoop can operate can operate in a single machine. This can be useful for experimentation, but normally Hadoop runs in a cluster configuration. As we can see here, a physical node, we have multiple physical nodes. We have different kind of job engine, job manager that runs the processing to that actually. So that's how it's kind of expands into exponential. And obviously the storage is cheap nowadays, and kind of inexpensive computing that we have in terms of that we can achieve this by using cloud capabilities, as well as high performance computing is possible, and the storage capabilities are kind of unlimited. And obviously open source, yes, there are some certain vendors as well. The commodity hardware is possible. This we're talking about more like on-premise, how we can deploy, how we can implement this to this. Moving on, in terms of there are certain things I would like to introduce in terms of how Hadoop ecosystem looks like. Obviously, Hadoop is governed by Apache Software Foundation, and it comprises the core services as we hear MapReduce, HDFS, and Yarn. In terms of that's a data services, right? So if you look at it, these are the common utilities and support modules that you hear. Yarn is nothing but a job scheduling, cluster resource management. Spark, that's a compute engine. A Pig, which is a data flow language. And Ambari this is where more like a UI to provision to manage the clusters. Scoop, which is nothing but bulk data transfer between Hadoop and relational, or how we talk about import export. So these are common terminologies which you hear within Hadoop aspects to that actually. So if I kind of move into this, actually this is what. So if you look at the storage, you have HDFS, that's where the file system, and the resource management is managed by Yarn. So these are the key aspects. This is actually how a ecosystem, Hadoop ecosystem would look like in terms of how it expands to multiple features, multiple, kind of support services, right? This is where exactly it gives us ability to store data, that means store files in like a non-relational store. These are different methodologies, different kind of the features that a data can be stored in terms of sentiment and clickstream, sensor, geography. So we can store any sort of data. And Hadoop is not just as a file store. Do not use Hadoop as your file storage or just a database store just for logs purpose. That means you be wasting the investment of IT and the time. There are certain capabilities of Hadoop. Obviously, it goes into, yes, Hadoop capabilities or extract, transform, and load. That gives us in kind of distributed computing, gives a predictive analysis, and we can build machine learning on top of that and graph processing. This is good. And Hadoop is not what I say that it's not a replacement for your data warehouse. Don't think that you're replacing whatever you have existing. It's not a replacement at all. And it's not a new place to learn the code. You are not kind of learning something new language to write. You continue what you're continuing to write in terms of programming, C#, .NET or Java, anything. So, and Hadoop is not a place for low latency data. As I said, it's not just for a simple kind of file store. It needs to be processed. It needs to be used. Like it's nothing but you're having like a supercar in your garage, and if you don't want to kind of use it, or if you don't have a license to drive, what's the use of having a supercar at your end? So Hadoop is like that. So make sure we make use the capabilities to the extent of that actually. Just going into kind of how HDFS in terms of how HDFS manages here actually. As you can see on the top here, name node, right? It says that name node. This is where it keeps all namespaces in memory, and it maintains the metadata in terms of each node and monitors the data node health. As you can see on the bottom, we can see multiple data nodes, and it replicates missing blocks. It manages everything, and as well as it maintains authorization, authentication of the data, so that it just keeps everything, manages its checkpoints, and the namespace changes as well. Whereas data node, as the name suggests, it serves as a data blocks directly to the the process, the services that trying to access the data, and it handles the block storage in multiple volumes and a block integrity. And this is where exactly it sends the heartbeat back to the name node saying that yes, I'm alive, and it stores the blocks as underlying operating system files. So this is more or less kind of under the hood how Hadoop manages, the HDFS kind of manages, and how it goes, the client reading the block, it goes to the name node, and it says that okay, that node, that data block is managed here on second data node. And not only that, actually, if some data is getting added. So this is more or less kind of high level overview of how it looks like, right? And these are many kind of industry use cases of Hadoop. I can say that. So this is what it is. They say store now, question later. So you can see that there are multiple kind of endless opportunities with Hadoop actually, how it has become, and we can see what are the capabilities of Hadoop as well. That's about Apache Hadoop. And moving into kind of what's Microsoft's answer to that actually, to big data, is HDInsight is a standard Apache Hadoop distribution offered as a managed services in Microsoft Azure. So this is where it is built upon Hadoop Hortonworks data platform and provisioned as a clusters that can run on Linux servers actually. The Windows has been kind of, now it's been retired. So it's only available as a kind of kind of Linux servers, Hadoop on Linux, and it offers the capacity on demand, pay-as-you-go pricing model. We can see all of these things, and it integrates with all other kind of Apache's core Apache Foundation software services such as HBase, Hive, Spark, Scoop methods, and everything. Any slide you can see here underlining to this, actually it opens up the slide for means information for you to look at a later time. So what is the ecosystem here? So how does HDInsight in terms of how Microsoft Azure HDInsight will look like? So this is the ecosystem in terms of, I just want to, I'm just clicking the slide to move on further because we have a set of amount of time here. So normally I present this on a SQL Saturday session where we have 75 minutes, but now we have a limited time here. So that's why I'm just moving into, quickly jumping into that actually, where you can see the red core Hadoop. These are kind of, how HDInsight and Hadoop ecosystem exists here. And the blue is nothing but data processing. As you can see, it supports scripting of pig language. Not only that, the existing kind of data integration, we have whatever in ODBC methods or JDBC or Scoop and REST methods. Not only that, the relational relational engines in terms of how Microsoft is in the gray color as we can see in the slide. Anyway, this is for your own amusement to read it later. So what is Azure HDInsight provisioning like in terms of positioning in the cloud? It's 100% Apache Hadoop. That means it's open source. It's given by the community. Whatever contribution made from the community is built into the Hadoop as well, into HDInsight. Powered by the cloud. Obviously, it is cloud and positioned as a platform as a service actually. So this is what it is. So as I said in the previous slide, actually we have HDInsight built for Linux only because HDInsight version 3.3 was last on the Windows. So obviously everything, if you want to transform the data transient from on-premise to the cloud, then this is where we have HDInsight is the answer to that actually. And these are different HDInsight cluster types we can build within the Azure cloud. Apache Hadoop, we can build a Spark cloud and as well as, the Spark cluster and as well as only having a HBase cluster. Also, we can have a Storm cluster. So these are different, the types of the clusters that we have within Azure as to provision. The positioning is here is actually platform as a service, obviously, because it's managed by Microsoft and we have the contributions, everything set back to the community, as I said, and as well as it has got, this is not an infrastructure as a service, the reason being that everything is managed by the Microsoft so that we only concern about HDInsight, we only concern about the data to that where we can see here. In terms of what are the different methods of SQL way with Hadoop, so these are the different, again, this is a slide I just want to give you a notion about what are the different services or technologies that can be helpful in terms of when you say about NoSQL on the left-hand side. We have HBase, which is a NoSQL type of thing, as well as the Cassandra, as well as MongoDB. So these are the layers and Hadoop supports having the SQL way of methodology, the support to the SQL type queries. So we can write in any of these languages or kind of methods to query the data to that actually. But this is just a notion to how it can do that. So not only that actually, so to HDInsight, we can make use of Visual Studio. If you have like the Visual Studio integration as of now, we can simply, no need to introduce any new technology here. You can still continuing of how we are doing this actually. We can do by using Azure Portal or using the PowerShell methodology where we can modify the clusters, we can add the custom scripts and as well as the Hadoop projects into that actually, and in different methodology here as we can see. It's got a deeper integration with Visual Studio here so that you don't need to bother about how I'm going to introduce a new integration methodology here. So it's not that. So it's got a complete end-to-end to that actually. Big data architecture is one thing I want to mention about. Lambda as an architect, you would understand what I'm talking about, but I'm just to give you an introduction of what's a Lambda architecture, which is a popular pattern in building the big data pipelines, right? It's on the both at a batch layer, which is called batch layer is nothing but a cold layer where data sits there, and as well as a speed layer, which is a streaming layer in terms of, hot processing of data, and that can be processed more in the transactional way and the real time, as we talked about. Transient data silos actually. Lambda pipelines create silos that can have some little problems in terms of how the speed layer can operate to the batch layer. But there are certain things like, like in terms of like how these can be come up in terms of how technology can help into that actually. So this is where Azure has got an answer to these, some of these challenges as we mentioned in the Lambda architecture. As you can see here, this is what it is, Azure Stack, in terms of how within Azure we have how we can do in terms of how structured data can go into a blob storage and then that goes into Databricks. We talk about Databricks as at a later slide, and as well as how it can go into Polybase using a Polybase methodology into Azure SQL Data Warehouse, and how it can be integrated with real-time dashboards using the Power BI. As you can see, there is a thin line between batch layer and the speed layer. On the top, we can see this is a speed layer. So all these Azure activities, these Azure services, we can see those are speed layer. And then the bottom, we can see the batch layer. So this is where exactly there are other ISV solutions are also we have that is possible here actually to us to put into into the context. What is a Azure Stack for big data? What kind of stack we do have? As you can see from left-hand side, these are managed kind of Azure Stack. As you can see, Event Hubs, IoT Hub, Azure Data Warehouse, machine learning, Databricks. And on the right-hand side, we can see these are all open source ones from Apache Software Foundation, HBase, Phoenix, Hive, HiveQL. Hive is nothing but the query language for Hadoop. Also the Kafka, right? And the blob storage is, this is where exactly we store the data in terms of which is a secure and compliant in terms of how you can manage and authenticate. So the authorization and authentication of your data access can be managed without any problem, and it is 99.99% SLA, and it is highly performant, and obviously multi-size petabyte can be accessed, can be stored, can be used, and it is kind of cost effective in terms of different tiers that Azure has got. And obviously it has got open source options. You have file system interface and as well as HDFS. So you don't need to move out of any other technology to write something here. Azure Event Hubs, right? So this is where in the beginning we just look into that. What is Azure Event Hub in terms of, it is used to auto scale. It is kind of, how your data can be accessed. That means the data streaming capabilities actually how it can be done. And it is compatible with the, the Kafka protocol. In terms of what are the Azure Event Hub for the big data? Obviously, the event hubs are fully managed as a platform as a service with just a little configuration management overhead. So, right, and if you look at from left-hand side, this is where exactly event hubs, event producers actually, that's the entity that sends data to an event hub. Event publisher can publish events by using HTTPS secure protocol or Apache Kafka protocol and AMQP. And each consumer would have kind of a specific partition and the subset to that actually, and it is grouped into the consumer groups so that we can set a stage that this data falls into this group. And the throughput unit we can set a certain number of units as a capacity to this actually. And if you move into further, so how does the collection in terms of the collection, as you can see, we can build our own cloud gateway APIs, or you can have a specific APIs to do that, and this is where ingress in terms of data ingress happens in the middle. So that's where it goes into fast data into slow data. We can mention that this data goes into kind of the area of fast data. That means it needs to be run, accessed by Databricks or done by Azure SQL databases or HDInsight. Cold data in terms of slow data just to access where you can do for log analytics at a later stage. And obviously at right hand side the presentation layer where we take advantage of to that how it can be done. So this is what Azure Databricks, as I mentioned in the previous slide, Azure Databricks is nothing but an Apache Spark based analytics platform optimized for Microsoft Azure Cloud Services platform. Obviously designed with the founders of Apache Spark, Databricks is integrated with Azure with a one-click setup actually. Streamlined workflows, we have interactive workspace and endless capabilities to collaborate between how data scientists and data engineers and business analysts can look into that actually. And obviously this is a Spark-based analytics services to build a big data pipeline right from the raw data ingested into Azure by using Azure Data Factory, and how it can be streamed is a near real time by using Kafka, Event Hubs, or even IoT Hub. So the data lands into the data lake in terms of how it can be accessed or into Azure Blob storage or Azure Data Lake storage, and they can build the analytics workflow on top of that. And this is a fully managed Apache Spark cluster in the cloud, managed by the Microsoft. As you can see, all the collaborative workspace to this, actually how the productivity can be increased. So in terms of how the advanced analytics, this analytics can, looked into picture, high-level picture of how it is from left to right, log files, unstructured and structured, as well as the custom apps. It goes ingest by using Azure Data Factory, Spark SQL, that's where it comes into the middle, the preparation and the train. So that's where Azure Databricks, we have that. And the real-time streaming, real-time data processing, and it supports and integrates with HDFS, Flume, and the Kafka. And also it's got internal machine learning libraries actually for common, algorithms and utilities. We can build our own common, kind of learning algorithms, but they have certain things. And it also supports a graph kind of database, which is used for a graph kind of computation for cognitive analytics and data exploration. Obviously, how the social applications, social media networks, how they use this graph. And obviously, it includes the Spark Core API has support for R, SQL, Python, Scala, and Java. So it supports everything into those areas as well. In terms of making this accessible, so that's how Microsoft Azure Machine Learning, which is possible. As I mentioned, it is enabled. It is available for you to build on top of that by using Machine Learning Studio and Machine Learning API services. Language, your data anywhere. That's what the idea is. You can run code in any language that you wish to, that you are continuing as of now. It can support different types of the file formats. As you mentioned here, CSV, JSON, Paraquet, and XML. They're more and more getting added into this actually. So this is what Azure is turning into more like how cloud, data, and AI. So this is what combined Azure gives us that capability to this, where we can build on-demand big data analytics. I do have some I'm going to support this presentation with certain scripts where you can try at your own. I have some video file as well where I can show how the Spark cluster or how the cluster can be added by using Azure Portal. So here I'm just talking about what exactly we have availability to this actually. Anyway, moving on. So this is how on-demand big data analytics can be built upon to this. Wherever the source data comes into as a cold path, you can store into Azure Blob storage, or you can use HDInsight for a later query, and it can build upon into the Power BI interactive query connector. And hot path by using Azure Event Hubs, as we have seen, and Azure Stream Analytics can add more value to that actually for us, where it can be stored into a Azure SQL database, like an in-memory column store, as you can see, and how it can be accessed by for the end user computation, such as by using dashboards or reports. There are certain things outside of this actually, obviously total cost ownership, deployment, and how it is this. Obviously, HDInsight supports auto-replication of data, a geo-replication. So data only replicates the same geopolitical region. So that's also kind of defined as per the Azure policies and the compliance. And HDInsight in the cloud bypasses deployment expertise. So you don't need to worry about it'll take a number of days to deploy. No, it takes number of minutes to deploy HDInsight cluster, and you spin up as many number of Hadoop nodes on demand, and we can scale up as well, scale out. Obviously, the cost, it's built by usage, built for usage, like, the clusters can be deleted or stopped or dropped when no longer in use. And obviously, Azure support includes by default whatever Hadoop support you have, whatever Azure support capabilities you have, it is included by default. And this is what it is in terms of, what are the things, just give you a notion of how it does. So in terms of, there are certain ways to create HDInsight clusters, obviously by using Azure Portal or Azure command line interface, and as well as the REST API. We can use, also you can build your own software development kit. Programming, existing ecosystems. If you are still kind of running the, kind of by using Mahout or Scoop, you can use existing ecosystem in .NET format in terms of C#, F#. If you're using .NET, any Java specific thing, you can still continuing on to that. Not only that, for DevOps and for IT professional, we have the PowerShell capability and as well as a cross-platform command line interface tools. So these are all capabilities already built in inside this HDInsight. What are the big data methods with tools? So here, this slide gives you kind of what are the different types of tools we can use in terms of getting into. For interactiveness, obviously the PowerShell and Azure Copy. For streaming of data, we have Apache Storm, we have RX, we have also custom related third-party applications. Azure Data Factory, obviously, the pipeline in terms of data orchestration. We can also use the PowerShell to integrate to schedule certain aspects, and SSIS as well in terms of, not only that, server log files. Obviously, the log files are more important, so how it can be used with the Flume, with SSIS, or you can build your own kind of custom solution to that. And relational database in terms of Azure Data Factory, it supports scoop methods in terms of directly by using SSIS or even Polybasin APIs. So these are the things it can be done. Obviously, it supports all of these areas. Why Microsoft Azure? Obviously, on-premises Hadoop comes with a kind of a cost, a big cost in terms of how we can manage, but whereas everything is now Azure. So, which is integrate with on-premises, so we can extend our data capabilities in terms of the on-premise as to the cloud. We can manage with both and rich services. Obviously, cloud offers Azure and other cloud providers offers the infrastructure as a service, platform as a service, and a software as a service. And obviously, the integration with heterogeneity of any kind of language, any kind of the CMS or any type of application, you can start building the application here. And obviously lowers the risk of data availability. The data is available and no data is lost. Everything is secured. Everything is secured in terms of how your Azure is kind of secured, the way, same thing. Again, a little back of how the mind mapping in terms of how it looks like in terms of a big data drivers. What are the key drivers inside from the business perspective, from the IT level strategic perspective in terms of where big data comes into a picture here. Actually, again, this is for information slide as well. I want to give you how it looks like, what are the key methods here, as you can see. Right, I think we're coming to end of the hour here. Just wanted to, before I give a chance for questions, I want to give summarizes of what is HDInsight. Yes, we have touch base in Azure Databricks, HDInsight and everything. HDInsight is nothing but a big data in the cloud. That means you can start running your big data environment within the cloud by taking advantage of Azure, Microsoft Azure. There is endless possibilities of storing data in terms of its reliable, and it can build distributed computations to this actually. And how I see a big data is just as another data source. It's not as a technology or something, but based on my experience, how I see that is nothing but just another data source. And I do have certain, kind of resources here actually, which you can try at your own time, at your own space in terms of, a certain Microsoft Virtual Academy, and as well as you can create our own HDInsight Spark cluster. There are some Azure labs here actually, and certain articles which I wrote about how data can be kind of managed or accessed. So this is what it is. I'm happy to share this slide after this session. You can email, or I think you can look into these meeting archives where you can download at your own pace and you can start looking into that. So I believe on that note, stopping the presentation. I'm happy to take any questions you may have.
All right. Adjust my microphone there. All right, excellent. The only question we had so far, and maybe we'll get a couple more while I'm going over this one, is getting the slides available for download. So if you just want to email those to me, I can get them into the meeting archive and we can make sure that folks have access to them that way.
Absolutely. I'll do that, Jason.
Great. And it doesn't look like we've got any questions. This has been excellent. I haven't paid attention to like all the big data things that have been coming through in the last couple of months, or actually the last couple of years, because there's just so much that comes all the time. This has been a great overview and giving us a chance to get caught up on all of that.
True. I've been presenting this topic actually in a majority of SQL Saturdays for the last 2 years. So it's been kind of all over, and it's been kind of reviewed and kind of versioned many times. If I look at my first slide of big data on Azure, I would look into that. Oh, that's laughable. But now it's moved on as technology moves very quickly and fast. it's enormous. Everything is changing day by day, so I have to keep up to that as well to make sure that I'm presenting it as at least the nearest possibility of what's there, rather than I'm talking about version 0.1 or something. So it's a constant learning, always.
Oh yeah. And then we just got a comment from Ken, and he's sharing that Microsoft Virtual Academy is actually closing down shortly. So if there is something out there that people want to take a look at, you probably want to get out there soon, and as they're making those changes.
True.
And
I think
before that's all shut down.
True. Microsoft Virtual Academy is something. Yes. That's really good point in terms of, I know I should have kind of kept that actually. Thanks to Kevin actually Ken, like actually how it is. I know that it's been kind of being retired actually. So now how they're putting that into is more like build Azure. I think they have certain, I think the other ways to that actually. We do have that. So yes, yeah. There is, Microsoft Virtual Academy is kind of closing down. That's for sure. But we do have other, but I'll update the slide anyway to just a way to go in terms of how we can build this actually. So.
Oh, absolutely.
Thanks. Yeah.
All right, and then one last, we'll go through the one last question that just came through here. Any suggestions on technology building in redundancy in case your data link to Azure has an issue? Having a stream going to somewhere local and then syncing once your connection is back up, or kind of thoughts around that.
Now, in terms of redundancy, that is guaranteed. Like in my experience, I have never seen anyone kind of having that kind of issue. I know it is really good point in terms of what are the other ways, if anything, or if the link is down to the Azure or something, how we can take. But obviously, we need to make our own arrangements to store data on-premise. Then again, obviously, that comes with a cost. But as of Microsoft Azure is concerned, everything is secure, everything is available. That means, yes, if it is not available at one region, it's obviously available in the other region. So that part of redundancy is managed by Microsoft very well.
Yeah, probably the only thing that Microsoft can't manage in that scenario would be if your own internet connection completely went down.
True. I think that's yep. Area, but as of now, there is no kind of capability where you can store this on-premise and they can take, because obviously the nature of the distribution, it's not possible to do that as of now. But hoping there should be something else would be available in the due course, how Microsoft can provide that in that scenario.
All right, excellent. Well, there are no other questions in the queue right now, so with us being at pretty much the end of the hour, I'm going to close things up. Thank you again for presenting today, and thank you everyone for attending the session. I look forward to having everyone come back at a future session, and Satya, if you'd like to present another topic in the future, please just let me know and we can get you on the schedule.
Absolutely. It's my pleasure, Jason. Thanks for the opportunity, and definitely come back with others. Thank you.
All right, thank you, and bye, everyone.